Good afternoon, everybody. I'm filming the seminar because I am even more narcissistic than my title would suggest. I've taken a bit of a risk with my title. The way I see it, it's a win-win situation for you. Either it will be the best seminar you've ever attended, in which case you will thank me and throw flowers at my feet afterwards, or it won't be, and you will have the schadenfreude of enjoying me falling flat on my face. I noticed this morning in the lift in biochemistry that not everybody shares my sense of humor. However, I am old enough and wise enough not to trust the opinions of people who scroll things in green ink. It's a well-known psychological trait. So, this is a divisional seminar. The point of it is for us to get to know one another. Perhaps it will engender collaborations. And so what I want to do is tell you a little bit about the work that goes on in my lab. I'm a protein crystallographer, and I'm therefore interested in the structures of interesting macromolecules. So let me just introduce you to a few of the players I want to talk about. We've worked for a very long time on a molecule called human serum albumin. It's a very abundant protein in your serum and in your tissue fluids. Has a very important function, which is represented here by one of the structures that we saw, which is to bind and transport fatty acids, an essential nutrient, around the body. It also soaks up an awful lot of drug molecules, and there's a great deal of interest in this protein from the pharmaceutical industry. We've worked on it for 10 or 12 years or so. We've solved in total 48 structures now deposited in the PDB. Some of them are listed here, but I will come back to this slide. That's one of the interests in our group. Most of our work is actually devoted to the studies of proteins that are involved in virus replication, and we're particularly interested in classes of virus which are positive sense and single-stranded. The most famous of those in our hands is foot and mouth disease virus. The virus contains a single molecule of RNA inside the particle, and that is expressed as a single long polyprotein precursor, which is cleaved by a virally encoded protease, and this 3C protease does most of the work and cuts up all the components of the polyprotein, which are required then to work together in order to assemble new virus particles. We solved the first structure of the 3C protease in complex with a peptide, and this work has led on to some interesting avenues where we're now exploring 3C as a potential target for antiviral development. We've also worked on the 2C protein, which I'd like to tell you about. Now, 2C, not 3C, is not a protease, it's a putative helicase, and we've done some interesting work, this was done by Trevor Sweeney in the lab, to try and map out the functions of 2C. Now, in addition to looking at proteins that the virus itself makes, we work on a number of proteins that are recruited by the virus in the infected host cell to assist with its replication. And we're particularly interested in translation, and these viruses have an unusual strategy in which a large RNA structure at the 5' end called the IRES binds host cell proteins such as PTB and LA in order to stimulate translation and regulate translation. And we've been interested in those for a long while, and one of them a long-term collaboration with Professor Steve Matthews, who's just arrived late at my seminar. PTB and LA are not viral proteins, they're host cell proteins, they have normal functions. PTB shown here, we've done a lot of nice NMR work, and recently we've managed to do some crystallography on these. But it has a normal function, and it's involved basically in splicing regulation. I'll get into the details later. LA itself is another RNA binding protein, also multi-domain, contains some RRNs, but also has this interesting LA motif. Now, as well as foot and mouth, we're also interested in another class of RNA virus, one which hits a bit closer to home in terms of humans, the caliciviruses. Has a single molecule of RNA. It has a protein attached covalently to the 5' end, which has an interesting but as yet not fully elucidated role in translation initiation. So again, a long-standing collaboration with Steve, but work done by Rex in his lab, and laterally now by Owen Lean in my lab, has solved the structure of the VPG protein. This is the first structure of that. And then this is the most recent result we have in our lab, which is due to Gabriela Biezzo, who's a project student in the lab for the last 6 months, This is our newest baby. This is only a few days old, so please don't speak very loud. This is the NS6 protease. Okay, so that's the sort of territory I've mapped out that I'd like to sort of go through. Now, if my calculations are correct, by this stage some of you are thinking, others of you are thinking, people towards the front are thinking, maybe one or two of you are thinking, okay? But many of you are probably thinking, I don't think this is shaping up to be the best seminar that I have ever heard. How is he going to get through all that stuff before 1:45? Well, I'm not. But I wanted to take the opportunity, really, to have a discussion about why this isn't the best seminar I've ever been to. Maybe you could think about what is the best seminar you've ever been to. One that sticks in my mind is a seminar I attended at Mill Hill quite a few years ago now, where Tom Stites talked through his sort of first results solving the structure of the large subunit of the prokaryotic ribosome. It was a really exciting time, not just because of the content, but he told a really good story as well. I'm sure you've seen excellent science presented in an extraordinarily tedious way. But when you have been to a really good seminar, have you ever thought about what was it that made it a good seminar? What were the things that worked? Many of us, we come to this is a weekly event. There are many other seminars around the college. What were your expectations? What normally are your expectations of a seminar? You're kind of thinking, it'll probably be all right. Sometimes you're disappointed, it's awful. Sometimes you're pleasantly surprised. Okay, it's better than your expectations. But a lot of the time, I think, if you're honest, the content more or less hits your fairly low expectations. Okay? You can tell me I'm wrong at the end. So I thought it would be a good opportunity just to sort of step back and have a discussion about the things that we think might make a good presentation. I think we can do better than we're doing. I've got my point of view on that, and I want to walk you through that rather briefly. I hope you don't find it patronizing. I'm not here to call out names or anything like that there. I'm not going to praise the good or damn the wicked. I've got my take on it. I offer it for what it's worth, but I think that we can raise our standards. So what is it that makes a good talk? When you're preparing one yourself, okay, you're pressed for time. Nobody really likes it. It is a bit of a chore doing the individual seminar, let's be honest, okay? The email that you get does say, look, it's a general audience and you should think about that, but how many of us really do that? So I wanted to sort of go through a few things that I think makes a good talk. The first question I think you should ask yourself is, who's my audience? Okay, is it a divisional seminar like this where it's a pretty mixed audience? Okay, we're all in the Department of Life Sciences, but we're not all biochemists, we're not all biologists. I'm a physicist. I know there are other physicists in the rooms, and I don't know the backgrounds of lots of other people. But you can imagine it's a general sort of life sciences background. What do they want out of the seminar? Okay, some of them are coming out of a sense of duty, and I think you have a duty as a speaker to give them something, okay? Entertain them. Don't waste their time. You might be fantastically interested in some minutiae to do with your data, but think about how many other people in the universe are. How many people cited your last paper? Was it 500? Was it 5? So those numbers are probably reflected in your audience. And all this boils down to is a matter of having respect for your audience. I know the chap with the green ink thinks that I lack a bit of respect for my audience, or perhaps have too much respect for myself, but I was writing with my tongue in my cheek when I came up with my title. Now the thing that's important, of course, is how long have I got? Okay, I know we're busy, we don't always have time to prepare as we might like, but I think it's very important to have the good manners not to overrun, although that is a sin I freely admit I have committed myself. Tell a story, okay? People like stories, and I think this is true even outside Ireland. okay? We like them very much, don't we, Owen? And I think they are universal, and people like a nice standard story, not necessarily a fairy tale. We're not talking George Lucas's particular ability to tell stories here, which is awful. A beginning, a middle, and an end. Okay, that's what people expect of a good story. So what do you put at the beginning? I'm surprised I have to put this up, but sometimes it's omitted. An introductory slide, who are you and what is your title, okay? I had my name on my slide, and I think that's good practice, just in case somebody didn't quite catch it when you were introduced, but put your name down. You never know, you might win a sort of interesting collaboration because somebody actually wrote down what your name was. Introduce the topic, so give context, okay? And of course how much context you give will depend very much on the type of your audience. That's where it comes in. Now, of course, at a conference you can skip pretty much all the introductory topic because everybody in the audience is up to speed on it. But set the context for your audience and give them the time to catch up with you. Okay? It's very easy to overestimate what the audience knows. You may think that you're flattering them, but I have never had anybody come up to me at the end of a seminar and say, "My God, you insulted my intelligence." Perhaps today, for the first time, it will happen, in which case I apologize in advance. But I think people are scared, actually, to make their science seem too simple and to sort of streamline the story so that it is digestible in a 40-minute slot for an audience that isn't quite up to speed with all the minutiae of your particular field, whatever it is. Tell the audience where you're going. Manage their expectations, okay? Do not use some grandiose title that you cannot hope to match, okay? And in your introductory remarks, give them some idea of what to expect, okay? And 40 minutes in, don't ever say, "and for the second half of my talk." In the middle, keep the story simple. Again, particularly if it's a general audience or even a departmental audience like this, I think you can be selective. I think, again, it's probably a greater tendency among younger scientists. You can be selective. You can edit the story. You do not have to tell it like it was, okay? I know we are all, carry the sword of truth in our scabbards with us every day as we go about our scientific business. Hopefully that's true when you write up your lab book and when you come to write up your papers. But when you give a talk, I think you can be a bit fast and loose, if I can put it so colloquially. But don't be misleading, of course, but vary the chronology. You don't have to tell it like it was. And if that doesn't actually give you a good story, if that interrupts the storyline, then change it. Save the details for the paper, okay? I do not need to see every single gel you have ever run. Trust me on that. Make sure you've got clear links between the elements. If your story's got multiple parts, it's a good idea to rehearse and make sure that the logic of going from one bit to the other is clear in your mind. That's the value of rehearsal. I've learned it through bitter experience. I pass it on to you. If you're giving a long talk, if you've got an hour to play with, then break up the flow. I would say, unless you're Stephen Fry or somebody who could talk the behind legs of a donkey, then I suggest that you give people a breather now and then, have an interim summary, tell a story, an anecdote or something about, something that went wrong in the lab about at a particular point when you were vying to get this crucial experiment completed. Break up, so keep it interesting. Make good use of slides, okay? We all use slides. They make it easier for us, but they're very easy to misuse. But we'll talk a wee bit about the details in a moment. And at the end, what did you hope to achieve by giving a divisional seminar? Okay? If it's just one fact that you wanted to get across, make sure you emphasize that and that's at the center of what you have to say. If it's to stir up some interest, then make sure you've given them enough meat to stir that interest, but you don't have to tell the whole story. If they are interested, they will go and read the paper, okay? They'll pick up the phone, they'll come and talk to you. You don't have to give them chapter and verse of the whole story, but you want to give them enough meat to chew on, okay, and to come back for a second course if that's your intention. Summarize your main messages very briefly, as I have done here. Okay, not whole sentences, not whole paragraphs, please, written across the slide, as I have sometimes seen. We have all seen that. Of course, make sure to acknowledge your co-workers, whoever they may be. So I can boil that down to 3 golden rules. Rule 1, less is more. You can leave stuff out and you will have more impact with your audience. Rule 2, less is more. And I think you can probably guess what rule 3 is. Keep it interesting. It's about telling a story. If you want people to listen to you, then make the story lively. And try to be yourself. I know when you're starting out, and I still get nerves before I talk, but you do get used to it a bit when you're starting out. It is absolutely terrifying. None of this stuff is easy, okay? Don't assume that anybody does it easy or talks well easily, okay? The people who talk well work hard at it, okay? They practice and they sort of try and figure out what's right. But try, if you can, to be yourself and to talk. Don't ever read a talk off. We're not doing history here or sociology where they just read stuff out and bore everybody else to tears. Nice story. Be enthusiastic about it. I have been to seminars sometimes where the speaker themselves did not seem very interested in their own work. And if you're not very interested in it, why are you expecting somebody else to be interested in it? So, I hope you're doing it because you love it and because you're quite excited about the results that you've got. And if that's true, then share that with the audience. They'll appreciate it. If that's not true, then maybe think about an alternative career or a different area to work in. If you're excited or depressed at some point, include that in the story. Everybody, that's a way of connecting with the audience. We've all got that experience. We've all had times when the experiment just blew up in our faces, or the beautiful theory that just was in our grasp fell apart, or whatever. Those are the things that enliven it. If you can, be dramatic. Give a sense of suspense about what you're doing. Mislead the audience, for example, about your real intentions in your talk. A few technical details. And I'm only including these really because time and again, you see them with younger people who don't have the experience, but I'm afraid it's true that even at professorial level, you see some very, very poor control of the projection facilities or understanding of what's going on. So a little bit about PowerPoint and whatnot. It's a very useful tool, but don't hide behind it. Don't stand and look at the screen here on your laptop and read it out. Okay, make sure that you look at the audience and just assume that they can look at the screen. It's a very powerful program, quite difficult to learn, has many powerful features. They seem to change it every 2 years, so it becomes incomprehensible again, but it's an important tool for you, so it's worthwhile spending time learning how to master it. If you sort of flip between PCs and Mac, PC to Mac, then there are other issues that you should simply get on top of. Plan your slides carefully with respect to color scheme, text, and figures. And I'll summarize I'll go through a couple of examples of that. And I have put this, there is tips on my website for anyone that can bear to look. Color schemes, okay? Very easy to get this wrong. Projections here, okay, this lecture theatre has been fitted with a brand new projector, I think, over the last summer. It works nice, used to be rubbish, okay? And generally the contrast on this screen is much less than the contrast on your computer. And many people don't appreciate that. So if you're not sure, then borrow a projector and just test out how the slides actually look on a projected screen compared to how they look on your slides. They always use high contrast color schemes just to play it safe. Try and use a consistent color scheme. That can be a good way of sort of linking themes. If a particular idea or whatever is always in a particular color, or a particular protein is always red, if it's suddenly green in the next figure, you're just making the audience work hard, and you can remove some of that work from them by using a scheme that guides them rather than distracts them from the content. Backgrounds. White, or actually I think strictly very slightly off-white is the optimum recommended. In a darkened room it might actually shed a bit of light on your notes if you actually have to consult notes from then to then, but it is a good, clean, neutral background. You still have to worry about your choice of colors. You might think it's obvious, but I've just seen mistakes made. I've seen yellow on white. Last year I saw yellow on yellow, which was a new extreme, but there you go. But dark colours, actually down to red, is okay. A lot of red, I don't know, I don't really favour it, but light colours, avoid it. It's a good choice if you're printing out stuff as handouts. Oh, I've lost one audience member already. Not too bad. I thought I'd be doing a lot worse by this stage. Blue backgrounds are a personal choice, a bit like drug taking. Do it if you want to. I personally don't favour it. But white is fine there. You have to be a bit more careful. Black doesn't stand out so well. Blue on blue is not so good. Red's awful, nor green. And a lot of men, 10% of men with sort of red-green colour blindness will struggle with things like that. This says, don't ever use magenta on blue, okay? Even though that is one of the defaults in Microsoft PowerPoint, okay? I don't know why. They're clever people, the people at Microsoft, but they offer that as one of the defaults. I've seen it used. It doesn't work. Light colours, of course, will work well. Dark blue, it's very imperial. But you've got to worry about the colours. Titles, you know, there's not hard and fast rules about this. It's quite a good idea. It makes you think about the content of the slide, gives the audience a cue about what's going on, and so, again, can be useful to keep them on track. I wouldn't have very long titles. I wouldn't have them running over a single line, for example, because then the audience just ends up reading everything. Which brings me on to text issues. And it's really not a good idea, I think, to put too much text. It's really not necessary to use the whole sentences. You should try to avoid ending up just reading the slides to people who can see and read them for themselves. This practice tends to annoy the audience because you're implying that they are illiterate. Now, if you're actually talking to an illiterate audience, this is a really good technique because it really impresses them. Much better, I think, to use bullet points and just capture the essence of what you want to say. Text legibility is another issue. Difficult to get right because screen size and room size varies from place to place. This is what different point sizes on a Mac look like on a screen, so I guess 24 is just about good enough for people with good eyesight at the back, is it? So, again, an issue to think about. Figures, you have lots of real estate. We have a lovely big screen here, but you often see figures that are sort of stuck in a corner for reasons that aren't always very obvious. Use the real estate that you've got. Add labels to the figures, again, give the audience plenty of steerage or steering. If you show something like this, that might be okay, as long as you're just trying to give an overall impression. Here, the overall impression would be that all these sequences are very like one another. You get that from just the color scheme. Okay, but if you start talking about this alanine residue here, then you are going to irritate people. So if you are going to talk about a particular feature, then do a bit of image editing, crop and zoom in on the bit that you want to talk about and display it in such a manner that people can see it. Again, I almost hesitated not to include this slide because it seems so trivial, and yet I think many of us will have seen this sin committed. I see a couple of heads nodding. If you're pressed for time, often you just sort of show a picture from a paper that you had, okay, that's fine. But if you're going to do that and you're just going to talk about the panel in the middle, then just show the panel in the middle, okay? Don't show people stuff that will distract them from your message. So again, learn how to use an image editor and crop stuff and zoom it out, add a few extra labels if you think that will help, add the reference if you can, and go like that. I did once see, we had a visitor here, it wasn't anybody at Imperial, but he showed a picture from a paper. It was a very nice paper, I think it was a Nature paper actually, but it was a figure that had multiple panels, and I counted down to panel P. And he showed every single one, and I think only actually talked about D. People who like to do microscopy, immunofluorescence is often problematic. This is a nice high contrast figure. I think you can all see it well. You have a very good projector here, but it is often difficult. Okay, you do have quite dim images, and it is sometimes difficult to get it to project adequately. But okay, you guys that do microscopy, that's a problem for you, and I suggest that you figure a way to solve it. Either show the negative, okay, the colors will be inverted, but you'll have better contrast, or just make sure that you bring a very high contrast or high power projector with you everywhere you go. But something to think about. I don't know what the solution is, but it's not on my radar. Other technologies, animating elements on slide can be very good, but as Spider-Man says, with great power comes great responsibility. So please don't overuse it, because again, it will just contribute to the distractions that you create for your audience. You can use video. You have to do so with care. We do a lot of structural biology. I mean, it's de rigueur for protein crystallographers to stick at least one movie in their slide presentation to show that they can do it. It's a real macho thing. There's endless problems moving videos embedded within slides from one machine to the other. I've had trouble even Mac to Mac, but Mac to PC, PC to PC, or whatever. Okay, if you are going to make a lot of use of videos, then grow a thick skin and insist that you use your own computer fuller projection every time. That's the only fail-safe way I've found of being able to do that. Animated transitions between slides, you have massive choice, but again, similarly with animated builds, a bit of judicious care. So, I'm going to wrap up in a moment. Take-home messages, nice and brief. Think about your audience. Think about why you're giving a seminar. I like stories. I think lots of people like stories, and that's a good way to get a message across. One of the golden rules. I think you can remember the other two. And attention to visual detail. It only remains for me to thank all the other people, or the many people who work in my lab, whose work I alluded to at the beginning. I did think that I would now say, okay, and now to get on with my talk. But I'll acknowledge all these are the people sort of who more recently been in the lab, and these are the present incumbents, to all of whom I am extremely grateful for their hard work and initiative and ingenuity. And with that, I would like to finish, and thank you for your attention.